Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 6, Lesson 8, Systems of Inequalities. So we've learned how to do inequalities and how to graph them. Now we're going to add one more element to it when we have two inequalities. Just like solving systems of equations, we're going to do systems of inequalities. Okay, so why? Here's an example of why we would use this. Okay, Jacqui is beginning an exercise program that involves an intense cardiovascular workout. Her trainer recommends that for a person her age, her heart rate should stay within the following range as she exercises. So as you can see here, the doctor wants her to stay within, or trainer wants her to stay within this heartbeat rate. It should be higher than 102 beats per minute. Okay, 102. Probably around here, and it should not exceed 174 per minute. The graph shows the maximum and minimum target heart rate for people ages 0 to 30 as they exercise. If the preferred range is in light green, how old do you think Jacqui is? Okay, so if she's within this range, how old do you think she is? Systems of inequalities. The graph above is a graph of two inequalities. A set of two or more inequalities with the same variable is called a system of inequality. Just like a system of equations, it's just now inequalities. The solution of a system of inequalities with two variables is a set of ordered pairs that satisfy all of the inequalities in the system. The solution set is represented by the overlap or intersection of the graphs of the inequalities. Okay. Solve by graphing. Okay, so here you have two equations, okay, and one is y is greater than negative 2x plus 1, which is here. And remember, if it doesn't have an or equal to sign, it has dashed lines. And it's greater than, so it's going to be above, so it's going to be this section here. And then y is less or equal to x plus 3, so it's this side here. And then they overlap in this green area here. So that's the green area is the answer we're looking for. Okay. Okay, so when graphing more than one region, it is helpful to use two different color pencils or two different patterns for each region. This will make it easier to see where the regions intersect and find possible solutions. So our solution here is everything in green. Okay, so let's try solving for this one. All right, so we have here y is greater or equal to negative 4. So you have negative 4, 1, 2, 3, 4, right here, and it is greater than. So the graph y equals negative 4 is this graph here. Notice, oh no, wait. It should actually be a solid line because it has or equal to. So we have this graph here as my first graph, and it's greater than. So it's everything on the top. So I'm going to just mark everything on the top here. Okay. And for this equation, I'm going to rewrite it so it's y equals is less or equal to negative 3x plus 2. Okay, so I wrote it in y is less than or equal to, move the 3x over here, so negative 3x plus 2. So start at 2, okay, and the slope is negative 3, so rise 3, 1, 2, 3, run 1. Okay, it's right here, those two lines connected, and it's going to be a solid line because it has that equal to sign. Try to make it as straight as I can. And it's less or equal to, so it's actually everything that is less or equal to. So you see here where they have intersecting shaded area. So it's this all the way here, and then you have your all the way here. So everything in the green area is what they're asking for. So if you do it in separate, different colors, it'll make it easier for you to notice. But it's everything that is in this green area. Nothing here in the red, nothing that's just blue. It has to be both intermixed, so it's right here. Okay, so we'll try another example together in the next slide. All right, so here's another 2, and this is going to be a little bit more complicated because it has red and blue on it. So I'll try to use different colors here. So you have y is less than 3x plus 8. So let's graph that first. Start y-intersection, 1, 2, 3, 4, 5, 6, 7, 8. Put your y-intercept there. From there, your slope is 3, so rise 3, run 1. 1, 2, 3, run 1. Okay, and y is less than that. So it's a dashed line, and everything is less than, so it's here. Okay, and then your second, let's see if we can pick a different color here. Let's do pink. All right, your second graph, y is greater or equal to 4x. So it starts at 0, 0 because there's no y-intercept. And rise 4, 1, 2, 3, 4, and run 1. Okay, so here and here you have, and it's a solid line. Try to make it straight, and it doesn't look straight, but let's say that's a straight line. And y is greater or equal to. So you see here where the green and purple or pink intersect. Let's do a different color here. It's actually this line here, everything in between. So it is this black area here that they're looking for. Okay, so next will be your turn. And go ahead, let's see, to the next slide. Okay, here's your turn numbers 1 and 2. Solve the system equations by graphing. If you can, use 2 different colors so we can clearly see which part you're trying to graph here. So do numbers 1 and 2 on a graphing paper, and then come back when you are done. All right. Sometimes the regions never intersect. When this happens, there's no solutions because there's no point in common. So if you have 2 graphs and they don't meet at all, then there's just no solution. Okay, such as this. When you have 2 systems of inequalities and you graph that and they don't meet at all, there's no intersecting colors, then the answer is they have no solution. Alright, so here's your turn numbers 3 and 4. Solve the system of inequalities by graphing. So go ahead to numbers 3 and 4 on a separate sheet of paper, and mind you, if they don't intersect, it is no solution. Alright, here is a real world example 3. Whole number solutions. Elections. Monifa is running for student council. The election rules say that for the elections to be valid, at least 80% of its 900 students must vote. Monifa knows that she needs more than 330 votes to win. Okay. Define a variable, write a system of inequalities to present the situation, then graph the system. So you gotta let R, the number of votes required by the election rules, 80% of 900 students is 720. So she needs R, the votes, she needs required votes to be greater or equal to 720. Okay, we're gonna let V be the number of votes the Monifa needs to win. So V has to be greater than 330. The system of inequalities is R is greater than 720 and V is greater than 330. Okay, so when you graph this, here is your 720 greater than 720. So it's going to be the right side. And then your V is greater than 330. It's going to be your top side. Okay. And where you see the green is where they intersect. Okay. Name one possible solution. Only whole number solutions make sense in this problem because there's no such thing as half vote. One possible solution is 800, 400. 800 students voted, and she gets modified receives 400 votes. So anything that's in this green shaded area is a possibility. So she could have had 900 students vote, and she could get all of 900 votes. So if that's the case, it could be right here. If it's another scenario here, let's say she got 700 students voted, or it has to be greater than 720. Okay, so 730 students voted and 500 votes she got. So anything in this green area is any possible scenario that she can get. Okay, go ahead to number 5. You're to number 5 about fundraising. This is a multiple choice question, so A, B, C, or D are your choices, and I believe this is the last slide. So when you're done with this, pack the homework in your book bag so that you have it for credit for tomorrow, okay? All right, thanks for watching.